Welcome back to another XDP Manufacturer Q&A. In this one, I'm joined by Justin from S&S Diesel to go over some common questions and misconceptions on the S&S CP4 to DCR Conversion Kit. This kit's been on the market for a while, so we wanted to get the inside scoop straight from the source. So Justin, what is the DCR pump and how does it differ from the CP4 internally?
So the DCR pump is actually a pump manufactured by Standardine, stands for Diesel Common Rail. We partnered up with Pure Power, which is Standardine's aftermarket division, to develop that pump that had already been in the market for 10 years to adapt it to the 6.7 Powerstroke. Internally, how it's different than the CP4 is it's an eccentric pump. So it has an eccentric ring and two plungers. The CP4 has two plungers in a V configuration, and instead of a eccentric ring, it has a aggressive two-lobe cam. So the CP4 will fire 4 times or have 4 pumping pulses per revolution, whereas the DCR has 2 pumping pulses per revolution. That's kind of the main differences, I guess, is the bottom end and the architecture of the pump, and which is why we really like the DCRs, because the eccentric design has already proven to be extremely durable.
You mentioned the difference in the drive gears. Can you elaborate more on the differences here?
Yeah, so the bottom end of the CP4 versus the DCR. The DCR is what's known as an eccentric pump. What is specifically called is an eccentric drive technology. What that means is you have a offset, basically a cam or a shaft with an offset, and then you have a drive ring here. And the ring just floats, and you have DLC-coated plungers that ride directly on that ring. So the ring isn't spinning, it's just floating, and what's nice is it allows for movement, just slow movements, not really fast spinning movements. The CP4, it is an aggressive two-lobe roller cam. So if you look at it, you have a cam, this spins, and it's got 2 lobes, and each time the lobe goes around, it goes up. So what we like about the eccentric drive is eccentric pumps have been around for a long time. That's actually what the CP3 uses. CP3 is an eccentric polygon, so it has 3 pumping heads versus 2. The CP3 has been around for over 20 years, and it has proven itself to be extremely durable over those 20 years. The DCR, which has been made by Standardine for over 10 years, has proven itself to be durable as well. So at the base of it, it's the eccentric drive, in our opinion, that allows the pump to be more durable, more reliable. Another feature of it is it has pressure lubricated bushings as well. So that's kind of something unique that the DCR has that not even the CP3 has.
So the DCR pump has been used out in the field for a while now. Can you walk us through some of the changes that you guys have made since the pump's release?
Yes, I guess one of the major changes we made early on is we did have 2 part numbers for model year splits, one for 11 to 19 and the other for the 20 to 22s. We recently revised the high pressure lines on the 20 to 22 models to fit all the years. And we also started putting a roll pin on the shaft to help with pump timing. It makes timing the pump much easier. It's not a keyway, it's not designed to hold any load. The taper of the shaft, that's actually what holds the gear on and holds the load. The earlier version DCRs that didn't have the roll pin, they were still able to be timed. It just took a little bit longer. One thing worth noting is that we experimented with multiple clocking positions to find basically what we consider to be the optimal timing to reduce vibration and harmonics. That's why we recommend timing the DCR. If, let's say, the DCR isn't timed for some reason, the pump isn't going to self-destruct. The main reason for timing the DCR is to reduce the vibration and the gear noise.
Now, what are some of the most common issues that you guys see with the DCR pump?
So we do a pretty good job of supporting the DCR. We got a good team of technical sales representatives that are there to answer the phone and emails. So we catalog every reported issue, whether it truly is an issue or an install error or customer issue. We record all of those. Out of those 751 reported issues, I'd say the most common thing is lines leaking. The sensor, I believe it's on the 15 to 19 trucks, you have to use a plug on one of the ports and then an adapter for the sensor on the other. And sometimes people will get those switched. And while they can thread into each other, they're not made to seal vice versa. And then they'll see a leak. And usually what it looks like is the crimp on the supply line is leaking, but it's usually dripping down from that leaky sensor. So that's one thing to keep an eye on. Broken lines, leaking lines, and that's usually a result of the brackets not being installed. Make sure that you're installing all of the saddle brackets on the high pressure lines. If you don't install that, or the tail support, if you don't install that, your lines will fail eventually. Another thing that can lead to high pressure line failure is not properly torquing the pump to the plate or using Loctite. So sometimes the pump, if it can work itself loose, then it will break high pressure lines that way too. If you do have broken high pressure lines, please contact us at ssdiesel.com or our phone number for proper troubleshooting steps, because we want to ensure that you're not going to just keep having leaking lines. There may be something else that's causing that. So just putting new high pressure lines on, you're not really going to fix the problem. But I'd say those are the most common reports that we get.
So it sounds like you guys don't really see a high failure rate on these DCRs then.
Yeah, actually it's, the DCR has been in the market for roughly 2 years, and we've been extremely happy with the warranty rate on it. I just checked this morning, 47,000 or what has been sold to date. Out of that 47,000, like I mentioned earlier, we've had 751 reported issues, and that is just a reported issue, not necessarily a verified true pump issue. Out of that 751, we've had 75 true warranties, and most of those have been other components of the kit, leaking lines, stuff like that. In terms of warranty rate, that puts us at a 0.16, a fraction of a percent in terms of true warranty rate. We're extremely happy with that. That's well below the industry standard. Yeah, and then I guess for the people that are potentially having issues, we have a database of, I guess you could say, common problems and solutions. And you can go to our website, the FAQ section, and we have a whole list of those, including common, I guess you'd say, error codes and stuff, and what the proposed solution should be. So yeah, we do have what I would consider to be an extremely low failure rate or warranty rate, but on top of that, we have a very good support rate, if that is a metric that people look at.
Now we're going to get into some common questions that we see on the internet lately when it comes to these components. When the DCR fails, what's the difference between that and a CP4 failure? Does metal still get everywhere?
No, it doesn't, and it kind of goes back to the base design or architecture. With the CP4, you have the hardened tool steel cam and rollers, and that's what creates all that fine metal debris. It will seize up and it just goes everywhere. And then the other, I guess you'd say, issue with the CP4 is that you're feeding the case first, and then fuel from the case goes and feeds onto your high pressure pumping elements. The DCR is very similar to the CP3 in the fact that once the fuel comes into the pump, the case and the high pressure pumping elements or pumping heads are fed independently with fuel. So in the case, if there is a failure, it's going to go out the return. The other thing too is the design of the DCR. It doesn't really make that fine metal debris. If you just kind of look at it here, you got a bushing there, and this just rides on here. So you don't have any surface where you have metal to metal tool steel, and it just does not fail in that same way.
So if you do everything you're supposed to do, maintain the truck on time, use high quality additives, high quality fuel, your CP4 won't fail. Is there any truth to that?
No. Based on our experience, you can have perfect fuel and a CP4 can still fail. You can change your filters religiously and the CP4 can still fail. At high quality additive, clean fuel, that's going to give you the best chances of your CP4 not failing, but it's not going to eliminate failures.
Are there any issues with the DCR spinning the crank gear like we get reports of with the CP4 pump?
Yes, there is. The crank gear spinning that's a Ford problem. That's a problem with the Ford engine, not necessarily a fuel pump issue. But when you do put more load on that crank gear or more load on the shaft of the pump, then you are increasing your chances of it spinning. For instance, like if someone puts a DCR on and then they also upgrade other components of the truck, add more power, command more fuel through the DCR does have 25% more displacement, so it has the potential to deliver more fuel and create more load if you require that of it. But that's not necessarily a DCR issue, that's a Ford issue. We've had at least one instance of a DCR failing, and it did spin the crank gear on the truck. In that case, we bought that customer a whole new engine. We don't like having to do stuff like that. We'd prefer that there not be any issues at all, but in the real world, things aren't perfect, and sometimes things do happen. The important part is we stepped up and did what was right.
Now, are there any common diagnostic trouble codes that could pop up after DCR installation?
Yeah, the ones that we get reports of most often are fuel pressure codes, like the P0087, that's a low fuel pressure code. And then the P0093, that's a large leak detected. And then you got a P0088, that's high pressure. So all the codes that we would get, and also the P228F, I believe, is also a fuel pressure related code. So they're all, those are the, I guess you could say, the four most common codes that we see, all fuel pressure related. And a lot of times this can happen just as a result of having the fuel system open. In most cases, the solution to those codes is actually all PCV related. The basically pressure control valve on the back of the rail, because you have the inlet metering valve on the DCR that brings the fuel in, but then you have the pressure control valve on the back of the rail that helps fine tune your rail pressure control. And a lot of times those can leak and you won't even see it because of the way it's designed. The leak actually goes out the return. So it could be leaking and you don't even know it. A common fix is just to really try and tighten the heck out of it, like as hard as you can, like turn on it. And it's got a tightening ring, so you actually have to hold it still with one wrench and then turn the collar with another wrench to try and get it tight. Another recommendation is just replacing the driver's side fuel rail altogether. That's a great solution, but we've also seen PCVs leak directly from Ford. So it's always a good idea, even if it's a brand new rail, to like put it in a vise and try and make sure that PCV is really tight. The high rail pressure isn't one that we get very often, but that's signs that you have fuel contamination. Because basically what's happening is that really fine screen on the PCV, it gets clogged with debris. And then it can't vent off pressure like it needs to, and then you get the high rail pressure code. We actually had a code like that on my friend's truck where it was one of the early DCR development trucks, and he took on a bunch of water and rust and did not know about it because he didn't have his water and fuel sensor active, and so then the truck ended up sitting for several weeks, and then he got that code. We bring it in, and what we find is that the PCV was just completely full of rust. And so that's what was causing that code, but then it led us to further inspect the DCR, and honestly, it's kind of a win for us because the whole inside of this fuel system had water and rust in it, and DCR included. And we have a YouTube video where we tear it down. The inside of the DCR actually didn't look that bad. We put it on a test bench. It tested just fine. We put it back together, and that DCR, that happened 2 years ago early on, and that truck has been running with that DCR in it ever since. All we did was the screen that was clogged on the PCV, we just took it off and put the PCV back in, and that same fuel system's running in that truck today.
So does the DCR pump flow more than the stock CP4?
It can, if the calibration commands it or asks for it. The DCR is designed to be a no tuning required direct drop in. It is going to deliver the exact amount of fuel as a CP4. The ECU won't really know a difference. But if you command it to deliver more fuel, it has 25% more displacement than a CP4, so it has extra headroom, I guess you would say. There's also a difference in high pressure fuel pumps between displacement and flow. Displacement is a constant, and so that's why a lot of the pump manufacturers use displacement to categorize like the size of the pump for pump sizing. Flow on a high pressure pump is variable. You have variable RPM, you have variable pressures. And I guess you could say the flow rate differences between the CP4 and the DCR change within all that. We completely mapped out the DCR at all the different pressures and RPM so that we could basically match the CP4's pump curve. I guess on average, we've seen as much as 35% more flow increase at max pressure, max RPM. At the lower RPM, lower pressures, it's gotten down to like maybe 10% more. So, in terms of flow increase, it's variable.
Is there an easy way to tell if my CP4 has been replaced with a DCR without having to pull the manifold off my truck?
Yes, there is. Actually, this is the low pressure line assembly that we include with the DCR. Easy way to tell is it's got this line here that clips into your stage 2 supply filter. This would also be the return on the DRV, so this is your return circuit as well. We use Gates hose on that, so if you see Gates on the hose, then chances are it's got a DCR in it.
For those people that are already running a return style bypass kit and looking to install the DCR conversion on their truck, is there any reason or any benefit to them keeping that bypass filter on the truck?
Yep. Well, I guess another common question we get too is, can I run a disaster prevention kit with a DCR? So it has a different inlet metering valve. So our disaster prevention kit, at least the bypass block portion, will not fit on a DCR. It's incompatible. It's not going to hurt anything to run the return filter because it's kind of separate. It's on the return side. You don't really need it with the DCR, but it doesn't hurt to leave it in there. The off chance that maybe the DCR does send some debris out the return or metal, then that return filter would catch it. So it's usually up to the preference of the customer.
That's a wrap on the S&S CP4 to DCR conversion. A big thank you to Justin from S&S for taking the time to answer our questions. To learn more and to get a kit for your truck, head on over to XDP today.